好。Hello, a new course named The Future Automobile. And my name is Liang Fei Xu. I am Associate Professor at the School of Vehicle and Mobility. And I'm also the assistant of Professor Ouyang. And tonight's topic is about new energy vehicles and the new energy revolution. And this lecture actually is totally prepared by Professor Ouyang, but unfortunately tonight he has a very urgent business to deal with, so apologize for this. Okay, so today's lecture includes 4 parts. First is trends of new energy vehicles and new energy system. So at the very beginning, I think I want to show you this this curve show the development of the new energy vehicle in the past 10 years. I want to show you this very impressive curve. This curve show the development of the new energy vehicles in China in the past 10 years. And here, the new energy vehicles, we normally include several parts. One is the plug-in hybrid passenger cars and plug-in hybrid city buses, and also the battery electric vehicles, which include the battery electric passenger cars and battery electric city buses. Okay, so this figure shows the amount of vehicle that is sold every year since 2010, and we can see that not only the total number increased very rapidly, but also the market occupation ratio also increases. Yeah. And all of this starts from 2010, and the changing point is around at 2014 or 2015. And after that, the increment is getting faster and faster. And based on some more detailed data, we can see that from 2011 to this year, China's new energy vehicle industry has grown very fast. And the annual output has grown from less than 2,000 vehicles per year, that is 2011, to this year the number is more than 2 million vehicles this year, 2021. And this year we only 9 months, so the number will be more. So from any way we can say that it is an amazing achievement. Yeah, it's an amazing achievement. Considering our history, we can say that this is the first time for China in our history to introduce high-tech and high-volume consumer products in the world. This is the first time. And also for our Chinese automotive industry, this is also our first time to lead the technical development directions in the world. I mean, the meaning we can say that this is an amazing achievement. So this is what is happening this year nowadays. So people will ask several questions. I think the most important question will be how does this happen, or why this can happen in China? What's the internal logic, or what's the internal reason for this? And the second question may be, will this successful experiences also be effective in the future for China? And will these successful experiences be learned or be used by other countries in the world in the future? So I think these are very interesting and very important topics. And actually, tonight's lecture was prepared facing these three important questions. Okay, so let's come to the first question. How does this happen? How does the new energy vehicle technologies in China changing or developing so quickly? So the story can go back to about 30 years ago. So in 1992, the first proposal to develop a new energy vehicle was proposed by Dr. Qian Xuesen, who is also named as the father of Chinese aerospace industry. Yeah, very interesting. He is the father of the Chinese aerospace industry, and at that moment, he was very interested in the developing of China's automotive industry, and he wrote a letter to the central government, to the leader, to explain his idea why Chinese government, why China needed to develop new energy vehicle, electric vehicles, and why this is a chance for us. But at that moment, China don't have this condition to develop this technology. Then, after waiting for more than 10 years, in the year of 2005, there was a group of experts which consists of the top-level research scientists and experts in universities, institutes, and all the companies in China. They prepared a report which explained the major challenging and the strategic choice of the transportation energy technologies. And in this report, the proposal, which was named as the energy efficient and new energy vehicles, which was later known by people as the new energy vehicle strategy, was firstly proposed. So in this strategy, the experts suggested to develop the new energy technology in China in two parallel ways. One is called the evolutionary strategy, which aims at improve or optimize the existing powertrain technologies. Or in other way, the aim is to develop high-efficient diesel engine, gasoline engine to improve its efficiency, to reduce its emission and fuel consumption. And the other way is to develop a new type of vehicle powertrain technology, which is named as the revolutionary strategy. And in this part, they suggested to develop some new technologies like the powertrain technology, like the hybrid powertrain technology, the battery electric vehicles, as well as the hydrogen fuel cell technology. Yeah, and behind this figure, there is a very detailed technical development matrix. And this matrix contains two dimensions. On one dimension, is the powertrain architecture, which can be separated into 3 major categories. One is the internal combustion engine, hybrid powertrain. The second is the battery electric vehicle powertrain. The third is the hydrogen fuel cell powertrain. Yeah, note that it is in the year of 2005. And on the other dimension, it's about the basic technical modulars, which is composed of the electrical control system platform and the electrical motor system technology, the battery propulsion system technology, the fuel cell hydrogen and fuel cell technology, and also the internal combustion engine hybrid powertrain technology. So based on these 2 dimensions matrix, we can see that there will be lots of detailed technical roadmaps. And actually, at that moment, about 15 years ago, there was lots of argument, lots of discussions on which kind of technology or which kind of technical roadmaps is the best for the Chinese automotive industry. And in order to answer this question, so actually the central government start several 5-year projects. So it starts from 2001, corresponding to the 10th 5-year project. And after 2 5-year projects, at the end of the 11th 5-year project, that is around 2008, there are all the different kinds of new energy vehicle powertrains were developed and demonstrated in the Beijing Olympic Games. Yeah, there were hybrid city buses, hydrogen fuel cell buses, and also battery electric vehicles. And all these technologies are compared with each other together. And also the cost, the durability, the reliability are evaluated for the market feasibility. Yeah, and at that moment, the results are not very good, because as a research project, all of these projects have very good result. We can say all the research projects were successful. Yeah, but it is not mature for the market introduction. And the only hope is on the battery electric vehicles, because for some other technologies, they have very big issues, like the hydrogen fuel cell. The cost was still too high, and also the durability is short. And for the internal combustion engine hybrid technology, it needs fuel consumptions and cannot be realized the zero emission. So the only hope relies on the battery electric vehicles. Yeah, and on the other side, for the battery electric vehicles, the development of the lithium battery trend is very the development of lithium battery technology. Here is the video of which was provided by General Motors, and we can see that for this lithium battery, yeah, this is a single cell, so lots of single cells composed of a modular, and this modular can be integrated with the vehicle chassis very well, and this technology makes the design of the vehicle very flexible, and also the performance of the vehicle very good. So we can see that the invention of the lithium battery has achieved a historical breakthrough in the field of storage batteries in the past several years. So this makes it possible to develop the new energy vehicles. So in the year of 2009, the consulting expert group make a make several discussions and decided to focus on the pure battery-driven technology, which means if we want to develop new energy vehicles, the first or the highest priority should be focused on the lithium battery and its corresponding pure battery-driven technologies. And after that, then we can, if we have this very good lithium battery technology, then we can develop this hybrid internal combustion engine hybrid vehicles, and then the hydrogen fuel cell vehicles. So this is the decision which was made on 2009. And after that, so all the central government and also lots of local government, that means the government for each provinces or each cities, provides lots of policy supports to support the development of the new energy vehicle, especially the lithium battery and the battery electric vehicles. And then this technology developed very quickly. Yeah, and nowadays we can say that in China we have entered the area of electric vehicles, and the develop process can be described as in China we can say as we starting from two ends, and then we go into the market for the high-class passenger cars. So the market of the electric vehicle can be separated into three parts. One is the large-size urban electric vehicles, and the other is the our own advantages. And the competition in this area is not so high. So we suggested the companies to enter this to market at first. And after we accumulate several experiences in technical development, then we can enter the medium and high-class passenger car market. So here, nowadays, we can see in China we have lots of very high-performing electric vehicles, such as vehicles provided by Xiaopeng, by SAIC, by Bike, by Xiaopeng, Xiaomi or Lixiang or Weilai, such companies. Yeah. So from any way, we can say that this strategy has a very good, very successful result. Yeah. On the other hand, with the scale development of electric vehicles, our lithium battery industry has also takes off. Yeah, this is a curve shows the development of the lithium battery industry. Yeah, this increment process is very similar to that curve of the new energy vehicle process. Yeah, and we can see that in the past 10 years, the cost of the lithium battery system decreased by about 85%. Yeah, and it is predicted that 5 years later, till the 2025, the cost of the lithium battery will be 0.5 yuan per watt hour. Yeah, and nowadays the cycle lifetime is about between 5,000 to 10,000 times, which means this lithium battery, its working lifetime can fully fulfill the requirement of the automotive application. Yeah, and not only is the cost, yeah, reduced very in a very big gap, but also the power density increases very rapidly. So the power density of the lithium battery itself increased from less than 100 watt-hour per kilogram to more than 300 watt-hour per kilogram. And also for the system level, the specific energy increased from around 40 watt-hour per kilogram to about 200 watt-hour per kilogram. Wow, this technical development is also amazing. It's also amazing. So totally, we can say that the battery technology of China nowadays ranks among the top 3 in the world. Yeah, and also the company CATL in China ranks actually first in the world in the battery industry. Yeah, so this is the achievement of the battery industry. And when we look into the key technologies, or when we look into the scientific issue of the lithium battery itself, yeah, we can see that the performance of for the mileage and life have been basically solved. So nowadays, the electric vehicles, the mileage, driving mileage of electric vehicles locates generally around 300 or 400 kilometers to 500 or 600 kilometers, which fulfills the requirement of our daily use. Yeah, but there are still several issues need to be solved. One is the thermal runaway for the safety problem. The other is the driving range decline problem in winter. Yeah, and the third is the super fast charging. Yeah, how to charge this battery very quickly. So our research also focusing on these several aspects. Yeah, and when we look into the research methodology, it is also very interesting. At the very beginning, before 2015, almost all the researchers in university as well as industry focusing on improve or optimize the material of the lithium battery. So lots of researchers or development work are focusing on the material. Yeah. But after 2018, the engineers and the scientists changed our viewpoint. Yeah, we start to improve the performance from the structure level. Yeah, that means we combine the knowledge from the mechanical engineering, from the electric and electronic engineering, together with the material science, and make new innovations. Yeah. And nowadays, almost all the research groups and the companies, we use multidisciplinary research method. That means we use not only the material science, but also the mechatronics systems, artificial intelligent technologies to develop high-performance battery systems. And the target is to realize a battery system that can guarantee a passenger cars that can provide more than 1,000 kilometers driving mileage, as well as to guarantee its thermal runaway safety and also its reliability in winter time. Yeah, and this is some pictures of our lab. This lab is named as Battery Safety Laboratory. It locates in the Automotive Research Lab, which is in a small corner of the Tsinghua campus. We have a total area of 1,000 square meters, and we have about 80 research staffs. And we focus on the battery safety issues. We have very complete equipment and research facilities. And one typical research outcome is, for example, we refilled the thermal runaway mechanism, thermal runaway mechanism of high specific energy battery. Yeah, so this type of battery is very popular in industry, but people don't know how the thermal runaway happens we do some research and make this secret be open to public, and we have some publications. Yeah. On the other hand, the battery is of course very important. But when we want to make the vehicle run, we need a very high performance electrical driving systems. So the electrical driving system also developed very rapidly. The IGBT was started to be replaced by SiC, and the volume can be decreased to 1 to 20% of the original design. And also for the whole system design, we start to design the electrical motor, the electrical control unit, the mechanical these technologies together with the lightweight design and together with the intelligent active corrosion technologies together, yeah, then we can design very high performance and also intelligent chassis platforms. And this kind of technology makes lots of possibilities, lots of makes the design of the vehicle very flexible. That means the vehicle can be regarded as two parts. One is the intelligent electric driven chassis, and the other is the body. Yeah, and these two parts can be combined, can be designed and produced separately and combined very compatible to form different kinds of vehicles. Yeah, we think this will make big change in the future, not only for the automotive industry, but also for our daily lives. Yeah, okay. So as a result, yeah, we can see that the new energy vehicle ownership increased rapidly till this number, 2020, and afterwards, based on the prediction of the report, which is named as the Energy Saving and New Energy Technology Roadmaps 2.0. This is a very, very important report that was published by the Chinese Society of Automotive Engineering. And in this report, it is predicted that in the future, the new energy vehicles the sales of new energy vehicles will reach about 40% to 50% in the year of 2030 of the total sales of automobiles. And by 2040, this number of new energy vehicles will be over half of the total sales of automobiles, and the number will beyond 300 million. So this is a very huge number. Along with the development of new energy vehicles, especially the electrical vehicles, the charging infrastructure facilities are also developing rapidly. So for the charging technology, we have two kinds. One is called the slow charge. The other is called the rapid charge. So for the slow charge, this technology normally is used in a resident area or public working area. And for the rapid charging technology, it is normally used in the intercity logic public light vehicles or intercity public connections. Yeah, and nowadays the slow charge facilities occupies about 85%, and the rapid charge about 15%. And this will and all of this information or signals indicates a big change in the automobile industry as well as in the energy industry. Yeah, when we look back into our history, about 100 years ago, yeah, there was a great transformation from horse-drawn carriages to automobiles. And then there was a great boom in the oil industry. Yeah, in the oil industry. So standing at nowadays, yeah, we think nowadays we may be also at another cross point of the technical change. So what will happen next in the next 20 or 30 years? We think there will be lots of changing in automobiles and also in the energy industry. So the development of automobile industry is always related to the energy part. So on the other hand, we have a look at the energy industry. So for the energy industry, the target or the development constraints is to realize the carbon neutral or the carbon peak of the energy industry. So based on this prediction, based on this report, it is stated that under the background of, it is said that in the year of the 2035, the renewable energy will account for more than 80% of the total installed capacity, and more than 40% of the produced electric energy. And also in that year, the cost of the renewable energy, here we mainly consider as the wind power and the PV power. So the cost of the PV power can be reduced to 0.1 yuan per kilowatt hour, and the cost of the wind power can be reduced to 0.2 yuan per kilowatt hour. So this number is very low. That means if we use the renewable energy as the original energy source, yeah, the cost of fuel or the cost of the operation energy for vehicles can be almost ignored. So this is a very good information for our automotive industry. Based on this result, we can make an analysis of the technical cost with different technical combination. So in this figure, all the energy comes from the renewable energy. So mainly the wind power, solar, or bioenergy. And the outcome of the powertrain includes the battery electric vehicles, powertrain, hydrogen fuel cell electric vehicles, and the traditional internal combustion engine. Yeah, and here we can see that there are lots of technical roadmaps. The energy how the energy comes from the renewable energy. It can go to the electrical power or go to the electrolyzer to produce hydrogen, or combined with some other materials to produce biofuels. And with this electric energy or hydrogen or biofuels or some energy hydrogen carrier fuels, we can go to different powertrains and have different efficiency. Yeah, it is. There are lots of complex technical roadmaps, and after some calculation, we can have some result of the efficiency. We can see the overall efficiency. This overall efficiency indicates the efficiency of the powertrain from the very beginning, the renewable energy. So all the energy, 100% of the energy comes from the renewable energy. When this energy, when we use battery electric vehicles to use this energy, the efficiency is about 77%. Yeah. When we use hydrogen fuel cell, the efficiency is about 30%. And when we use traditional internal combustion engine, the efficiency is about 13%. Yeah. So we can see that the battery electric vehicle, if we don't consider, if we only consider the wheel-to-wheel efficiency, the battery electric vehicles have a very obvious advantage. over some other technologies. And the hydrogen fuel cells is worse than battery electric vehicles. Yeah, but if we use hydrogen fuel cells, they have advantages in driving mileage or the charging time or the refueling time. Yeah, but the internal combustion engines, it seems there's no reason to develop such technologies in the future when we use 100% renewable energy. Yeah, so this is a major conclusion. So based on this, in our future development, the technical roadmaps are mainly focused on the battery electric vehicles and on hydrogen fuel cell vehicles. So this is the reason or the internal logic why nowadays almost everyone in automobile industry or in the energy industry are discussing about the electric vehicles or hydrogen fuel cell vehicles. Yeah. Okay, so let's further focusing on the energy system. So this figure shows an energy system, the principle of an energy system. It is a little complex. Let me explain a little for you. So on the right-hand side is the consumer side. We can see that there are lots of consumers, such as such as for the building, for industry, yeah, for some other facilities. And on the right side is the power source end, and we can see that there are the major power source comes from the wind, the solar, yeah, and also there are energy storage facilities like the battery, like the battery, the water electrolyzer, and also the electric vehicles. Both the battery electric vehicles and the hydrogen fuel cell electric vehicles can be also used as a facility to store energy. Can be regarded as a facility for energy storage devices. And for such a complex energy system, there are four basic elements which called the power source, the network, the power load, and the energy storage part. And these four elements is the four basic things that compose this complex networks. And for these complex networks, it is necessary to develop intelligent control or intelligent management systems based on big data or based on faster communication system. Yeah, and when we look into the energy part, when we go back to the history, we can see that. So actually nowadays we are at the third energy revolution. The first energy revolution, in the first energy revolution, our human society, the power source of the human society changed from the firewoods to coal. So this is what happened in the first energy revolution. And for the second energy revolution, the power source of our human society changed from coal to oil and gas. And nowadays is the third energy revolution. So the power source of our human society may change from oil and gas to renewable energy. Yeah. So here renewable energy contains the wind power, the solar, the biofuel, or some others. And as a basic technology, the third energy revolution contains three parts. One is the green renewable energy. The second is the efficient energy storage technology. And the third is the intelligent digital network. Yeah, when we go further, yeah, we can see there are more elements. We call it the 5 pillars of the new energy revolution, which the first is the renewable energy as a power source. The second is the energy production or the energy consumptions changes from centralized centralized style to distributed style. That means the coordination technologies becomes much harder or difficult. Third is we need to use hydrogen or battery to store the intermediate energy, and the fourth is we need develop the energy internet technology. That means to distribute or connect this coordinate the energy production and consumption. And the fifth, which is also very important, is that the battery electric vehicles will also be regarded as an energy consumer and also regarded as an energy storage for the energy grid. Yeah, so this is a basic idea. So this is the idea from the electric vehicle revolution to the new energy revolution, and also to the artificial intelligence revolution. So this is what is happening nowadays, not only in China but also all around the world. And in our viewpoint, we think the electric vehicle revolution is the center of all of this technical transformation. Yeah, because the electric vehicle revolution contains the power technologies, and also the artificial intelligence technologies. And the electric vehicles can also serve as a battery storage in the new energy system. So it is also an element of the new energy revolution. And in the control or the coordinate or the information level, there is the artificial intelligence revolution, which also influence the electric vehicle revolution and also the new energy revolution. Yeah. So these three revolutions combined together, we call it the intelligent new energy systems. Yeah. So the outcome of all the revolution together is the intelligent and new energy systems for everything. Yeah, for the transportation system as well as for the whole society. Yeah, so this is what we think that will be happen in the next 20, 30 or 2030 or even longer time in the future. The second part is the battery energy storage and the vehicle network integration. As mentioned above, we can see that among the three revolutions, the electric vehicle revolution is the center of the three revolutions. And the battery technology is the center of the electric vehicle. So the battery is a key point. So the battery or the energy storage technology is a key point. And there are lots of energy storage technologies nowadays, like the lithium batteries, like the flow batteries, hydrogen, and some other technologies. And generally speaking, they can when we focus on the electrochemical technologies, we can see that there are two major kinds. One is the energy storage batteries, and the other is the hydrogen energy storage technologies. Yeah, and the batteries and hydrogen energy have their own characteristics. They are highly complementary and will become the main method of energy storage in the future. Yeah, and these two technologies can be named as the electrochemical energy storage technology, but there are still some challenges. One is the cost. Yeah, the cost of the electrochemical energy storage is still high. The second is the safety. Yeah, here we provided two videos which was happened in China several days ago, and we can see that the accident was very serious. And based on some statistics data, the fixed energy storage station, which was composed of battery. Normally, the storage battery capacity is more than 10,000 kilowatt hour. So this is a very huge number. And normally, for such kind of capacity, it contains almost normally contains 10,000 to several thousand single cells, and which makes the accident probability very higher. So normally it's about 1%. That means it is very possible to for such fixed storage station to have such kind of accident. Yeah. So based on these two technical challenges, there's an idea of the V2G technology. So the V2G technology in this part is a vehicle to grid V2G interactive energy storage technology. That means to use the battery in electric vehicles as a movable, a portable energy storage device. Yeah, this is the basic idea. And the possibility of this technology is that based on our statistical result, more than 90% of personal cars are are parked, are not used, and this for these cars, the battery inside these cars can be used as energy storage system for the energy grid. So that's the basic idea. So by using this technology, we can greatly reduce the cost of building fixed energy storage stations on one side, and also we can improve the safety, because for each vehicle there is a battery management system in the vehicle, and this management system will control or will monitor the states of the battery inside, and this and the safety of the battery inside the vehicle is much higher than the safety level of the fixed of the battery in the fixed storage station. Yeah, so this is the basic idea. And how does this happen? Here gives a basic idea of this technology. So on these two curves, there is the curve with the blue shadow. Yeah, this line. This line is the power requirement, traditional power requirement without electric vehicles. So normally there are two peaks. One appears in the morning, and the other appears at night before people go to sleep. And when we use and based on this, we can use the battery electric charging and discharging power. We can add this battery charging and discharging power onto this curve. And the precondition is that if the battery charging and discharging behavior is not suitably controlled, the peak will get much higher. Yeah, the peak will get much higher, and the lower part which will get much lower. So this is negative things. But if the charging and discharging behavior can be coordinated, or can be controlled, or can be management suitably with some intelligent technologies, then the peak can get lower, and the value part can get higher. That means the electrical power requirement curve can be much flat, and this is very desirable for the energy grids. So this is called the disordered charge and ordered charge. Yeah, and for more details, there are some calculation which was reported by some England report in this report, and they give this result. This result showed that if all the electric batteries are not coordinated, are disordered or not coordinated, and when the number of electrical vehicles increases, we need to increase the charging and the discharging power of the national grid. This is almost unacceptable because increase of the power means larger power means bigger charging and discharging facilities, means larger charging and discharging current, more cost, and much lower safety. Yeah, but when we use the intelligent ordered charging technology, this power can be reduced. When we use V2G technologies and with this intelligent disordered charging, the power requirement of the energy grid may even be reduced. Yeah, so all of these are can be realized based on big data and intelligent technologies. So this is advantages of this V2G interactive charging technology. And this idea can be generalized to other parts. For example, we start from the V2G, and then we can use we can develop V2V, V2 load, vehicle to home, vehicle to building, vehicle to microgrid, and vehicle to the grid in the national level. Yeah, so there are lots of things or innovation space, lots of chances to do scientific research and also to do innovation in industry. Yeah, and here is the comparison of the battery energy storage technology, which we use the fixed battery energy storage system, and on the other side we use the electric vehicle as the battery energy storage system. This is a comparison, and we can see that the capacity of these two are similar to each other. Yeah, but with the electric vehicles, we don't need extra investment to build fixed storage stations, and the charging time of the fixed storage station is fixed. But for the battery electric vehicles, it needs different flexible, intelligent charging time, and for the building space, for the fixed BESS, it requires some space to store the fixed battery. Yeah, but for the EV BESS, there's no requirement for the space and no requirement for new investment, and the risk of the safety is much lower. So the only cost of the EV BESS technology is we need to develop an artificial intelligent systems based on big data. So we need mathematical, we need code, we need some software to improve the whole system. Yeah, and if we have done this, the later cost will be none. Yeah, so that's very good technology in the future. Yeah, and then we will evaluate the potential of such EV BESS technology. We can see that this technology has big potential for the energy supplement and also for the power supplement. On the energy side, we can see that we estimate the situation in 2040. Yeah, it is assumed that there's around 300 million EVs in China. And all of these EVs can provide onboard energy storage capacity with about 20 billion kilowatt hour capacity, which is the same as China's daily electricity consumption at those times. So that means if we use these intelligent systems to coordinate the electric vehicles all over China, and then the discharging energy can provide daily use. Yeah, that means in ideal situation, there's no need for renewable energy production. Yeah, that's the ideal situation. And the other side, this technology has very great power potential. Yeah, and based on one estimation for the situation of 2021, for example, in Beijing has about 500,000 EVs, and this number, the power support of EV can reach about 7 million kilowatt, which is 1/4 of the maximum load of Beijing this year. Yeah, that means if we use the electric vehicles nowadays in Beijing as the battery as a power source to provide power to the grid, then about one third of the power can be supplied by the energy from EV, and the rest, that means the power supplement of the grid can be reduced by one quarter. Yeah. So that also means we can reduce the investment of the charging facilities about 1/4. Yeah, it's a very big number. Okay, so how does this technology can be realized? This is here gives a basic idea. So normally we can separate this technology into 3 layers. This is a local layer which deal with the interactive charging and discharging facility activities, and the other is the emergency layer, which combines different information together and realize some algorithm to decide which vehicle needed to discharge to the grid, and which vehicle needed to charge from the grid. And on the top is the coordination layer, which collects all of the data from different agencies. Yeah. And also we start to do some demonstration projects in China. This is a project in Beijing around Zhangjiakou. So in Beijing in Zhongzai building, and in this figure we can see that we combined the PV power, the mobile energy storage, and the national grid and the building together to have a flexible energy distribution system. And for this V2G technology, we also developed a roadmap to realize this total intelligent systems. And it is predicted that this technology will be realized about in the next 5 years. It will be realized the ordered charge. That means all the battery, all the electric vehicles, the charging and discharging behaviors will be coordinated by some intelligent algorithms. And after that, the V2G, V2 Home, and some other technologies will be developed, and till 2030 or 2040, the total system will be realized. So this is our target. And later I will shortly introduce the hydrogen and fuel cell technologies. Yeah, As we all know, as introduced just now, the third energy revolution contains 3 key point technologies. One is the green renewable energy. The second is the energy storage technology. The third is the intelligent, artificial intelligence technology. And for the energy storage, there's the battery storage and also the hydrogen storage. Now, hydrogen storage is also very important. Yeah, this explains compares the technology of green hydrogen with the energy storage battery. Yeah, we can see that they have different properties. Yeah, properties. The green hydrogen is normally centralized. Yeah, it stored energy in a centralized style. Yeah, and also generate power in a centralized style. And for the fuel cell, it is more suitable for long distance and heavy duty traffic situation. And also the cost and some other technical bottlenecks are much higher than the battery electric, higher than the energy storage battery technologies. And hydrogen will be used in lots of aspects. For example, the high-duty, long-range driving situation for like heavy trucks, the trams, boats, and also the aviation situation. Yeah, and hydrogen production and hydrogen for hydrogen technology, there are 2 aspects. One is the fuel cell technology. For the fuel cell technology, the principle of fuel cell technology is to change the energy in hydrogen into electric energy, and there are in automotive industry we call it the fuel cell engine. Why it is the fuel cell engine? Because it looks very similar to the internal combustion engine. The core inside the fuel cell engine is the electrochemical reaction cells, and the balance of plant of this fuel cell stack, it contains the air supply system, the hydrogen supply system, and the cooling system, which is very similar to internal combustion engine. And here we can see there are some examples provided by General Motors, Honda, and Hyundai. And in China, in the past 20 years, we have developed hydrogen and fuel cell technologies using a top-down technical roadmap. That means we start from the powertrain technology, then we focusing into the fuel cell engine technology, and then we focus into the fuel cell stack, and finally we go into the memory material level. Yeah, and this is some examples of our research project about 10 years ago for the hydrogen fuel cell city buses, which was demonstrated in Beijing Olympic Games. Here we designed a very complex distributed powertrains with fuel cell engines as a core part, and also some network communication and control systems. And this project was led by Professor Ouyang, and here is some figures in the 2008 Beijing Olympic Games. And at that moment, we have fuel cell city buses, fuel cell passenger cars, and China's first hydrogen station was also built at that moment. Yeah, and after that, we focus according to the top-down strategy. Yeah, we change our focusing point to the fuel cell system. So we developed 4 generations of fuel cell engines with Tsinghua High Tech and group, and also we developed advanced fuel cell stack with single fuel cell company, and the performance of this GN3 series is very close to the top level internationally. Yeah. Also, these technologies gained attention from President Xi, and this technology has highly positive comments from the central government. And nowadays, the durability of the working lifetime of the fuel cell system exceeds 10,000 hours, and in some cases it can even reach 20 hours. That means this technology, in terms of durability, it can be used in automotive applications. Yeah. Later in the Winter Olympic Games, which will happen very soon, in several months later, there will be a hydrogen and fuel cell demonstration project in these Winter Olympic Games. There are several areas which we build lots of hydrogen refueling stations, and there will be around 1,000 hydrogen fuel cell vehicles operating in this area in the routines between Beijing, Zhangjiakou, and some areas. And in the future, it is predicted that the cost of fuel cell system in the next 5 to 10 years will reduce 80%. That means the total cost after 10 or 20 years will be 20% of the cost nowadays. And this this process is very similar to what has happened on the lithium battery in the past 10 years. Yeah. And this is our very roughly prediction of the fuel cell development in the future, in next 5 to 10 years. And we think in the next years there will be a very big jump in the number of the fuel cell vehicles, as well as the hydrogen charging stations, and also the cost will be greatly reduced, and all the performance indices will be greatly improved. On the other side is the technology of the water electrolyzer. So water electrolyzer can be regarded as an inverse process of fuel cell. So for the fuel cell, the hydrogen and oxygen meet together to produce electric energy and to release heat and water. And in the water electrolyzer, we fed the system with electric and water, and the outcome of the system is hydrogen and oxygen. So this technology can be regarded as store the electric energy into oxygen and hydrogen. Yeah. And on the right hand side is a protocol of the electrolyzer. And for this technology, there are several sub-technologies like the alkaline electrolysis, proton exchange memory electrolysis, and the solid oxide electrolysis cell. So each technology has different properties in the dynamic response behavior, and also in the cost and life. And currently, we can see that the alkaline electrolysis has the lowest cost and relative lower cost and relative high durability. But for all of these technologies, the durability is the common issue, the common challenges. And in the future, the durability needs to be improved and the cost needs to be reduced. And in Tsinghua, in our research group, this is the prototype which was designed by our research group and produced with cooperative companies. It is the PEM water electrolyzer, which can produce in hydrogen with this facility. And also we developed another prototype of the SOEC, the solid oxide electrolyzer cell. yeah, with some Chinese cooperative companies. And also there are lots of technical tools for hydrogen storage. It can be stored as compressed gas, high compressed gas with 700 bar or 350 bars, or it can be compressed with CC hydrogen, and also it can be compressed, can be stored as the liquid hydrogen. And also the hydrogen can also be storage in material-based technology, like the foreign technologies. So nowadays, in this part, there are also different technical roadmaps on how to produce hydrogen, how to storage hydrogen, and how to distribute hydrogen. And another very good technology for hydrogen storage is to use the ammonia. Ammonia is also very important, and this technology is highly developed in foreign countries, such as in Japan and in Europe and also in US. And we think the ammonia has very good advantages in the energy storage density and especially its cost. So in China nowadays we are comparing different technical roadmaps for hydrogen and to find one most suitable technical roadmaps for China for the hydrogen and the fuel cell industry. Yeah, and as a result, we can see that the hydrogen is the one of the best choice for long-term and large-scale renewable energy storage. Why? Because it is adequate of energy utilization. That means the storage efficiency is very high. And the second is the price is relatively lower than the battery storage system. And also it is complementary with battery storage system. And the production, transportation, and storage is very flexible. It has different technical roadmaps. And on the other side, we can see that there are also technical issues of the hydrogen production, storage, and distribution, and there are lots of work that need to be done in the future. And for this part, there's also different demonstrational project in China to compare different technologies. For example, this project is in Zhangjiakou, and we will combine the technology of new energy vehicles, including the battery electric vehicle and hydrogen fuel cell vehicle, together with hydrogen refueling station and battery charging station, and also together with the wind power and the PV power as a renewable energy to evaluate the technical cost, the life cycle cost of different technical roadmaps, and maybe after several years we will find a relative good solution for the future development. And the fourth part is new energy science and technical research and development in our research team, which was led by Professor Ouyang. And this is the major member of our research team. There are 4 professors and 4 associate professors, and me as Liang Feishi here, and 2 assistant professors and several research staffs. And the total research member is about 100. We have totally around 100 research members in 3 major directions. Yeah, and around us we have 15 companies that is established by our students, and all of these companies focusing on several key points which is related to new energy vehicles. Yeah, and in the past years, our research results successfully gained attentions from the central government, and Professor Ouyang introduced the several research results to our leaders. And also, there's a very big international cooperation project called the Sino-US Cooperative Project on Electrical Vehicles. And this project was started in 2011, and nowadays this project is still going on. And in this project, the two sides do researches on lithium batteries and electrical vehicles, and there are lots of joint publications in the past few years, and also some cooperation outcomes among companies on the two sides. Yeah, and the research area of our group, there are several parts. One is the battery storage and the green energy system, and the other is the electrochemical energy storage battery system, and the fourth is the hydrogen energy and fuel cell systems, and the fourth is the hydrogen electrical intelligent energy power system. And yeah, this is corresponding to each research field, we have some cooperative companies with us. Yeah, now comes to the end of this lecture. So as a result, I think after developing for more than 20 years, the new energy technology is nowadays is at a historical point, and later it will develop even much more rapidly. Yeah, and in the future, the new energy revolution will promote the third new energy revolution will promote the fourth industrial revolution, and which featuring green and intelligent technologies. And in the next decade will be a new area of new energy, electric and intelligent revolution. So there are lots of opportunities to do high-level scientific research, and also to do innovations in industry, to establish new companies, and to make lots of startups. Yeah. And finally, I think we come back to the three questions at the very beginning. So for the first question, how does this happen? How the new energy vehicle development so rapidly happen in China? I think the answer is the cooperation. Yeah, we cooperate. There's a cooperation between university, institute, research institute, and also the industry. And the central government plays a very important role in this cooperation. And I think this cooperation is the reason why we can collect different ideas for different units. And after collect these different ideas, then we do complex evaluation, and finally to make a decision. So this is the answer, my answer to the first question. And for the second and the third question, can these successful experiences be still effective in the future in China? I think, of course, yes. Yeah, it can be. It will be effective in the future, because we have this good mechanism to organize the cooperation. And for the third question, can these success experiences be effective for other countries in the world? I think yes, of course. Yeah, why not? The cooperation can be done in different style. Yeah, the important is the change of the information. Yeah, so if we can make the communication channel between the university, between the industry, between the research institute, and between the industry very fluently, the knowledge exchange, very good, and then we have a very good idea collection and decision-making mechanisms. And I think for any countries, we can do similar things. We can develop our own technologies in the future. Yeah. So finally, I think let's work together to join the green revolution and create a better world. Thank you. Okay. So any questions?